Hey guys, I am Alwilkins Burgos, and today we're going to talk about the secondary consolidation settlement. This is the part after the primary consolidation settlement. First, we must look back from previous topics, the components of settlements. The total settlement of a foundation can be expressed as ST equals SE plus SC plus SS. ST as the total settlement, SE the immediate settlement, SC and SS as primary and secondary consolidation settlements respectively. So the total is the summation of the SC, SC, and SS. Secondary consolidation settlement happens due to the changes in the particulate structure of the soil. It occurs very slowly long after the primary consolidation is completed and is time dependent. It is most significant in saturated soft clayey and organic soils and peats, or the organic soils from organic matters that are decomposable. That's why secondary consolidation settlement is important in these kinds of soils. The ratio of secondary to primary consolidation increases as the ratio of stress increment to initial stress decreases. As the ratio of the secondary settlement SS and the primary consolidation settlement SC increases, the ratio of the change of P or the average effective stress and the PO or the vertical effective pressure decreases. Take note that PO is the average effective stress at the mid-height of the clay. According to Braha M. Das, secondary settlement is more important in anorganic, highly compressible inorganic soils. In over-consolidated inorganic clays, the secondary consolidation index is very small and of less practical importance. So if the soil is overly consolidated or the PO is less than the past effective stress that is over consolidated clay, what happens is that the secondary consolidation index or the slope of the loading curve becomes smaller, and that's why secondary consolidation settlement is neglected if the soil becomes overly consolidated. So as you can see here, we have the relationship between the void ratio and time, where the time is in logarithmic scale. We also have the loading curve in color blue, and this represents the variation of void ratio and time. We also have the secondary compression index CA, or the slope of the tangential line, which is equivalent to the change in void ratio all over the difference of T2 over T1. So we have the formula SS is equal to change in E times height or H all over 1 plus EP, or in other books EF. EP is the void ratio at the end of primary consolidation. To get EP, as you can see, we have two tangential lines. These lines, when intersecting, the point at which they meet now becomes the EP or the void ratio at the end of primary consolidation. Also, that is the point where we can get the time T1 or the time that the primary consolidation has ended. To get the slope or curve of the secondary compression index CA, it is simply equal to the rise over run, where our run is equal to the change in E, and since the time is in logarithmic scale, it is now change in E all over the difference of T2 minus log T1, or simply change in E all over the logarithmic ratio of T2 over T1. Arranging the formula, it has now become change in void ratio equals secondary compression index CA times the logarithmic ratio of T2 over T1. Finally, substituting the values, we can get the formula SS is equal to C alpha H over 1 plus EP log T2 over T1, where CA is the secondary compression index, H as the thickness of clay layer, T1 and T2, time of completion of the primary settlement, and EP as the void ratio at the end of primary consolidation. As what I had said earlier, EP is the final void ratio for the primary consolidation that is equal to the initial void ratio or EO minus the change in E. Now, what are the values of C alpha? The general magnitudes of C alpha as observed in various natural deposits are as follow. For over-consolidated clays, it is equal to 0.001 or less. So as you can see, it is really tiny. As to what Braha said, it is so tiny that it can now be neglected. For normally consolidated clay, it ranges from 0.005 to 0.03, and for organic soil, 0.04 or more. We will also use the formulas for the degrees of consolidation and how the amount of consolidation affects at a given time within a soil mass. We will use the formula of U is equal to SCT over SC to be used for the entire depth of clay at any time t, where U is the degree of consolidation, SCT as the settlement of layer at any time t, SC as the ultimate settlement of layer from primary consolidation. Also use the formula U is equal to 1 minus UZ all over UO to be used for getting the degree of consolidation at a distance Z at any time. Where again, U is the degree of consolidation, UZ as the excess pore pressure at the time T, UO as the initial excess pore water pressure. We will also use the formula T1 over T2 is equal to U1 squared all over U2 squared to be used for getting the relation of the time and degree of consolidation. U1 as the degree of consolidation at time T1 and U2 as the degree of consolidation at time T2.
Hi guys, so after our first reporter explain about the secondary consolidation settlement, we're going to provide an example problem. So a normally consolidated clay layer 3 meter thick has the following properties. Initial void ratio equals to 0.8, compression index equals to 0.25, average effective pressure equals to 125 kilopascal, expected pressure increase equals to 45 kilopascal, secondary compression index equals to 0.02, time for completion of primary settlement is equals to 1.5 years. So the question is, what is the total settlement of the clay layer 5 years after the completion of primary consolidation settlement? So here, so the first step we're going to do is we're going to use this formula, which is S, which is the total consolidated settlement equals to primary consolidated settlement plus secondary consolidated settlement. So first here, we're going to solve for the primary consolidated settlement, which is okay. Sorry. Which is SP or the primary is equals to H times change of E over 1 plus initial void ratio. So, ato ang change of E diri or change of E na to is equivalent to ang compression index, which is ang CC log PF over PO, where atong PF or the final pressure, no? Final pressure is equivalent na siya sa PO plus change of P. Okay? So now, we're going to get, since nalaman tayo H na given, at og initial void ratio, so need na to i-compute na to ang change of E. Which is, ang equivalent is, butang ang yung mga values. So, ito ang compression index equals to 0.25, you know, 25 log log. So, itong PF. So, equivalent daw sa PO plus change of P. PO is equals to 125 plus 45 over PO. So, 125. So, we get the value of change of E. Change of E is equivalent to 0.0334. So, i-calculate na po ninyo para check if tama ba. So, so karon na naman tayo value of change of E. Kuha na nato ato ang value for the primary consolidated settlement. So, ito siya yung input. So, SP is equals to H. Ang H is 3 meter thick sa given. 3 meter. So, para ano na siya daan into millimeter. Convert siya into millimeter. Ito na siya i-convert dito. So, which is 1,000 millimeter, sorry, over 1 meter. Huh? So, times na itong isa na change of E which is 0.0334 over 1 plus 0.8. So we get our value of our SP is equals to, is convert na ito nyo, cancel na siya. Ano? So we have the value of 55.667 milli. Yung unit is millimeter na. So second is kuha naman itong primary. We're going to solve for the secondary settlement na to, which is SS is equivalent to, so itong SS is equivalent to, zoom gamay, SS is equivalent to C prime alpha H log times T2 o T1, which is ito ang initial o atong final anto. No? So, sorry. Medyo pangit siya. So, nito to ko na to una ang C prime pa. Okay. Natay given na. Kanina natay given sa H. T2 nata, T1 na. So, C prime alpha is equivalent sa C alpha over 1 plus E sa primary. So, solve ko sa E prime. So, 3A, equivalent ng EP na to is equals to E initial na to minus change of E. Ang change of E na gamiton 3A, which is kani nang nasolve na to 3A. Okay? So, makuha na to itong EP which is 0.8 minus 0.0334. So the value of 0.7666. Okay? So makuha na nato siya. So makuha na nato ni siya. Since namin tayo value sa C alpha. So C prime alpha is equals to C prime alpha diri C prime alpha or the secondary compression index CO diri CO si alpha ni siya. Sorry for the si alpha ni siya. Balik ko ba ito? Balik ko denote. So itong value sa C prime alpha is equals to 0.02 1 plus 0.7666. So we're going to get its value equals to 0.01132. Yun. So, gamit na ito siya kayo na naman given Mara na may kulangan formula sa taas. So, S secondary is equals to input lang na itong value which is 0.0132. So, itong i-zoom dito gamay maklaro ninyo. 32 times h, which is ang h natin dito kay 3 meter. Convert gyapon natin siya dito so to convert na is 1,000 millimeter over 1 meter. So cancel out and log. So to ang tito diri sorry. So itong tito diri given problem what is the total settlement of the clay layer 5 years after daw. So money after. So final na to which is 5. Okay. And ito ang is itong time after sa completion sa primary settlement which is katong 1.5 years. So natin 1.5 years. So since cancel out naman so ito ang unit magamit is millimeter. So simplifying, we get the value of 17.757. So now we can get our total settlement na. Basta na ito ibutang daw. Dili na ito ibutang. Dili dapit. So we get our value of S is equivalent to equal to 55 667 plus kailan tang isa kanina 17 ano to na ba to? Okay, sorry 17.757 17.5 7 sorry Mali. 7, 5, 7. So, terms of I'm not sure guys ha. So, we have get the value is equals to ano siya? 73.424 millimeter. So, man itong settlement after 5 years. So, that's all for the problem, guys. I hope you have learned a lot in this problem. So, that's all. Thank you. And we're going to proceed for the another problem.
So in this example, we have a soil formation shown in the figure has its groundwater table located at 2 meters below the ground surface. The ground surface is subjected to a uniformly distributed load of 40 kilopascal, and we need to find or compute the primary compression index. Next is compute the primary consolidation settlement of a normally consolidated clay layer. And the third, compute the secondary settlement of the clay layer 5 years after the completion of primary settlement within 1.5 years. Then we are given with a secondary compression index of 0.02. So first, we need to find the primary compression index, which is denoted as CC. And based on the Skimton's equation in 1944, CC is equal to 0.09 or 0.009 rather times LL minus 10, where LL is our liquid limit. Since liquid limit is not given in the problem, however, there are values of liquidity index, plastic limit, and moisture content of 0.64, 20%, and 40% respectively. Using the formula of liquidity index, we can get the value of liquid limit. So, the formula of liquidity index is given as Li is equal to moisture content minus plastic limit all over liquid limit minus plastic limit, and substitute values given in the clay. We got 0.64 for our liquidity index equal to the moisture content of 40% minus 20% of plastic limit over the unknown liquid limit minus 20% of plastic limit. So, in finding the value of our LL with a given formula, we are going to substitute values. So, 40 minus 20 all over cross multiply 0.64, then transpose negative 20 to the other side, it will become plus 20. We got a value of 51.25 for our liquid limit. Then we substitute the value of 51.25 on the Skimstone equation. (09) 51.25 minus 10, which gives us the value for our primary compression index of 0.37125 rounded off at 3 decimal places. We get 0.371 0.371 as our primary compression index, which is our answer for problem number 1. So next, we need to find the value for our primary consolidation settlement of a normally consolidated clay layer. In finding the primary consolidation settlement of a normally consolidated clay layer, we are going to use the formula of SC is equal to CC times the height all over 1 plus A primary or initial E log over PF over PO, where PF is equal to PO plus delta P. And since since the values in our formula are already given except for the PO, we need to find PO using the process of finding the effective stress and recall that the effective stress, which we are going to denote as PO, is equal to the effective stress total minus the neutral stress or the neutral pressure. And since in finding the value for our effective stress, we need to gather the values for our unit weight per layer. And here in the illustration, gamma dry is already given in sand, and the gamma saturated for our sand is also given. However, the saturated unit weight in our clay is not given. However, we are given with the specific gravity of 2.60 and the void ratio of 0.60, which are components in finding the gamma saturated in our clay. So, we need to find first the value for our gamma sat. And recall that the formula in finding the gamma sat is equal to the ratio of specific gravity plus void ratio times the gamma water or the unit weight of water over the summation or the sum of 1 plus void ratio, and substitute all the values, we can get gamma sat. So G is or the specific gravity is given as 2.60 plus the void ratio of 0.60 multiplied by the gamma water of 9.81 over 1 plus the void ratio of 0.60, which gives us the value of 19.62. Then we calculate the value for our PO, which gives us first, we put the total pressure, which is gamma dry of sand 17.66 times its height of 2 meters plus the gamma sat of sand, which is equal to 20.93 multiplied by its height of 3 plus the gamma saturated in clay, which is 19.62, and its distance By the way, going back on to the figure, we need to find the gamma sat, or the effective unit weight, at the mid layer of our clay. Let's assume this is our PO. Sorry for that. So we are going to find the value of PO on the mid layer of the clay, in which this is 2.5. And this value is going to be multiplied on our gamma sat that we solve, which is 19.62 times 2.5. Then the neutral pressure is equal to 9.81 times the distance of 2.5 plus 3. And from here, we solve the value for our PO, which is 17.66 times 2 plus 20.93 times 3 plus 19.62 times 2.5 minus the neutral stress, or the neutral pressure, of 9.81 times 2.5 plus 3, which gives us the value of 93.205. Since we've got the value for our PO, we then solve the value for the primary consolidation settlement. So SC is equal to the value of CC, which we've already solved, 0.371 times the height of the clay, which is 5, all over 1 plus the E, or the void ratio, of 0.60 logarithm of PO 93.205 minus, or plus rather, plus the change of P, which is given as 40 kPa, all over 93.205. Which gives us the value of 0.1797 rounded to the 3 decimal places. SC is equal to 0.180 millimeter. Next, we are going to find the secondary settlement 5 years after the completion of primary settlement, and we are going to use the formula of SS is equal to CA times its height 1 plus EP log of T2 over T1. Every values are given except for the EP. In finding EP, we are just going to subtract the values of the initial void ratio to the change of void ratio. And based on the previous video under the topic of primary consolidation, the change of E is equal to CC logarithm of P final over P initial. And again, P final is equal to PO plus change in P. And substitute the values, we could get the value of E of 0.371 logarithm of PF, which is 93.205 plus 40 over 93.205, 0.0575. Rounded to the 3 decimal place, we got 0.0580 or 0.058 rather. And we then substitute the value for our delta E to this equation. We could get the value of 0.542, and this 0.542 is the value for our EP here in the formula of secondary settlement. And the values to be substituted here, CA is given, or C alpha, and the height of 5 meters, and the value for 1 plus EP, or EP is equal to 0.542 times the logarithm of 5 years for secondary settlement and the 1.5 years accumulated under the process of primary settlement. Substitute all the values in the formula. 0.02 times 5 all over 1 plus 0.542 times the logarithm of 5 all over 1.5, which gives us the value of 0.0339, or in 3 decimal place 0.034 meters. And in terms of millimeters, this is 34 mm. So the SS is equal to 0.034, which is equal to 34 mm. That's our final answer. And thank you.
Here's another example. A soil profile is shown in the figure. A uniformly distributed load of 50 kPa is applied at the ground surface. The clay is normally consolidated. Number 1. Compute the compression index. Number 2. Compute the primary consolidation settlement. Number 3. Compute the secondary settlement 8 years after the completion of primary consolidation settlement. Time for completion of primary settlement is 2 years. Assume that the secondary compression index is equal to 0.025. So I have here the sketch version of the figure. So for number 1, compute the compression index. So we have this equation for compression index, or CC, which is CC is equals to 0.009 times liquid limit minus 10. So sa problem, walang binigay na liquid limit, but may given void ratio as well as specific gravity sa clay. So pwede natin ito silang gamitin to solve for our liquid limit by using these equations. Since sa problem, it was stated that the clay is normally consolidated, pwede natin gamitin itong equation ni Nagara and Murphy equation. So, E, or our void ratio, or initial void ratio, divided by void ratio at liquid limit is equals to 1.122 minus 0.2343 log effective stress, wherein void at liquid limit is equals to liquid limit divided by 100 times GS. So to get the LL, we need the values of GS, which is given na siya, as well as the value of void ratio at liquid limit. So, to get this, gagamitin natin to. Na kung saan, given na yung ating void ratio, ang kulang na lang is yung effective stress. So, to solve that, balik tayo sa figure. So, PO So, before, PO was defined as the average effective stress at the middle of the clay. So, middle. So, dito siya makikita itong red circle. So, dyan daw, malolocate natin yung ating PO. So, to solve for PO, pwede natin ma-apply yung learnings natin sa stresses in soils wherein yung mga solid layers below the water table, maminusan natin ng unit weight of water. So, for this problem, so, PO is equals to our first layer, which is above our water table. So, height niya is 3 times yung unit dry natin na 16 kilonewton. So, hindi natin siya maminusan ng unit weight of water since wala siyang tubig. At the same time, nasa taas siya ng water table. So, plus height of our second layer, 6 times the saturated unit weight of the sand, which is 18, minus, since below water table siya, it means may tubig siya. So, maminusan natin siya ng unit weight of water, which is 9.81. Plus, since, diba, PO was defined as the average effective stress at the middle of the clay. So, hanggang dito lang yung height ng ating PO. So, at the middle, which means kalahati siya ng 6 meters. So, 6 divided by 2, 3 meters. So, 3 ang height times yung saturated unit weight natin sa clay na 19.08 minus still maminusan siya ng unit weight of water na 9.81. Yun. So, PO natin ngayon is equals to, so, cycle natin, 3 times 16, 6 times 18 minus 9.81 times 19.08 minus 9.81. Oops, 81. So, PO natin ngayon is equals to 124.95 kilonewton per meter square or kPa. So, yun. May PO na tayo. So, pwede na natin ma-solve si EL. So, sa problem, E natin is equals to 0.08, 0.80 rather, divided by EL natin equals to 1.122 minus 0.2343 log effective stress natin na 24.95. 24.95. So, EL natin ngayon is equals to, cycle natin, 0.80 times divided by EL is equals to 122 minus 0.2343 log 124.95. Shift solve. So, EL natin is equals to 1.268. So, may EL na tayo. So, pwede na natin masolve si liquid limit, which is ito. So, EL is equals to LL divided by 100 times GS. So, pwede natin to siya, yan na lang, idiretso. So, 1.268 which is at ang ating EL is equals to liquid limit divided by 100 times yung GS natin na 2.7. So, LL natin now is equals to 1.268 equals to 100 times 2.7. 46.963. So, masasolve na natin si compression index, which is CC is equals to 0.009 times liquid limit minus 10. So, CC is equals to 0.009 times liquid limit natin na 46.963 minus 10. So, ang ating compression index now is equals to 46.963 minus 10. 0.333. So, ito na yung answer natin for number 1. Answer for number 1. So, that's all for problem number 1. So, for problem number 2, compute the primary consolidation settlement. So, based sa previous reporters, we have a formula for primary consolidated settlement, which is ito. So, CS is equals to compression index times height of our clay divided by 1 plus our initial void ratio times log times PO plus change of pressure divided by DO. So, kanina sa number 1, we already solved for CC as well as PO. So, all we need to do now is to substitute those values para makuha natin si CS. Si SC rather. Since given naman si delta P, si H, as well as si E. So, for number 2, SC is equals to our CC, which is 0.333. So, 0.333 times height of our clay, which is 6 meters, divided by 1 plus our given ratio na 0.80 times log times yung solve PO natin na 124.95 plus delta P, which is given 50 kilonewton per meter square. So, plus 50 divided by 124.95. Okay. So, our SC now, SC for our primary consolidated settlement is equals to 6 1 plus 0.80 log 124.95 plus 50 into 4. So, our SC now is equals to 0.162 meters, or If gusto natin siya i-convert to millimeters, times 1,000, 162 millimeters. So this is now our answer for our problem number 2, which is the primary consolidated settlement number. So for the last problem, which is number 3, compute the secondary settlement 8 years after the completion of primary consolidation settlement. Time for completion of primary settlement is 2 years. So assume secondary compression index or C alpha is equal to 0.025. So dito, hanapin doon natin yung secondary settlement 8 years after the completion of our primary consolidation settlement. So may given tayo or may binigay na time T1, which is 2 years rather, and for T2 equals to 8 years. So may binigay din na C alpha na equals to 0.025. So since yung hinahanap is secondary settlement, may formula tayo para doon, which is ito. The secondary consolidated settlement or SS is equals to C alpha times H, steel height of the clay, divided by 1 plus EP or the final void ratio times the log of T2 divided by T1. So, given na yung T2 natin at saka T1 as well as the height and the C alpha. So, yung kulang na lang natin to get the SS is this final void ratio wherein we have these formulas. So, final void ratio is equals to initial void ratio or EO or E minus change or delta E, wherein delta E is equals to CC log times PO plus delta P all over PO. So, given na yung P ang ating initial void ratio, ang kulang na lang to get our final void ratio is this delta E, which is ito. So, may nasolve tayong kanina na CC as well as PO. As well as given na rin yung ating delta P. So, makukuha natin si delta E, makukuha na rin din natin si final void ratio. So, for this one, So, delta E is equals to CC, which is 0.333 log PO natin na 124.95 plus yung delta P natin na 50 divided by 124.95. So, delta E natin ngayon is equals to 0.333 log 124.95 plus 50, 124.95. So, delta E natin is equals to 0.049. So, makukuha na natin si final void ratio equals to initial void ratio natin na 0.80 minus delta E 0.049. So, final void ratio natin ngayon is equals to 0.751. So, pwede na natin makuha si secondary consolidation settlement, which is yung space. Hindi siya makita dito. So, SS equals to si alpha natin na 0.025 times height of our clay, which is 6 meters, divided by 1 plus yung ating final void ratio na 0.751. Yun. Log dito natin na 8 years divided by 2. So, SS natin ngayon is equals to 0.025 1 plus 0.751 log 8 divided by. So, SS or ang ating secondary consolidation settlement is equals to 0.052 meters or times 1,000 52 millimeters. So, this now is our answer for number 2. Rather number 3. Yeah. So, all in all, yun na yun. So, answer natin for number 1, CC, which is equals to 0.333. For number 2, 0.162 meters or 162 millimeters. And for number 3, 0.052 meters or 52 millimeters. That's all for this example. So, if you have any clarifications or mayroon kayong hindi naintindihan sa pag-explain ko, you can just comment on the forum. That's all.